All right, folks, we're still in section 4.5. This is the second video that I'm doing here, and I want to look at the second method of solving our exponential or our logarithmic equations. And you'll notice that for my second tip, we have a log equation. Actually, tip number 2 and tip number 3 are both log equations, but I want you to see the difference. Here, I have a log on one side, but just something else that's not a log on the other side. The difference is that in number 3, I have a log on both sides. So that's the difference between these two tips. Right now, we're only going to deal with tip number 2. So when you have this log equation, you want to get your single log alone. And then the way you're going to solve is by using exponentials. So we're going to go down to example 5 and example 7. So if you would follow me then, I'm down to example number 5. I have two different possibilities here, two different examples. I'm trying to solve, which means I want to get x alone. And secondly, I'm going to be answering with exact values. I'm not going to be answering with approximations. Now, one of these examples is a log that is alone, and one of these examples is a log that is not alone. Which one do you think has a log that is alone? And what we're looking at here is this one on this side, this log is alone because it's only a log of whatever it is I'm taking the log of. This one is a log of x that's being multiplied by a 4. So this log is not alone. And so my tip says that the very first thing that you want to do is you want to get the log alone. So we're going to divide on both sides by 4. On the left, this will give me ln of x, and on the right-hand side, that's going to give me a 9. So my log is alone. Okay, the directions then said, once your log is alone, use exponential. So remember, back in section, the previous section, 4.3, this is where we said, hey, my base raised to, in this case, the 9th power is equal to x. And this was the symbol that we used to be able to change my logarithm into an exponential. So we're going to have my base of e raised to the 9th power is equal to e. Remind yourself of what you're trying to do. You're trying to solve. You're trying to find out what x is. Yep, we got it. And we were supposed to give exact values. If you take e raised to the 9th power and you plug that into your calculator, you are not going to get an exact value. You're going to get an approximation. So we're finished with this one. All right, let's go over to part B then. Part B, we've already established that my log is already alone. And so what we're going to do is we're going to turn it into an exponential and solve. So once again, we're going to start with our base of 3, raise it to the 1st power, make it equal to this guy in the quantity. All right, so 3 to the 1st is equal to x cubed minus 5. Let's add 5 on both sides. And then x is going to equal 2. All right, so that's example number 5. Let's look at example number 7. So for example number 7, once again, I have a single log. Now it's big and ugly, but it's still just a single log. It's alone on the left side. And so we're going to take our base of 3, raise it to the 3rd power, and make that equal to, sorry about that, make that equal to our quantity. Okay, so 3 to the 3rd is going to equal, I went ahead and FOILed these two binomials together. I got 4x squared plus 5x plus 1. And then my 3 cubed is a 27, so we went ahead and moved that to the other side by subtraction. I was able to factor, and then I can solve my two factors. X is equal to negative 13/4 or x is equal to 2. Now, you'll notice that over here on the side, I have shown that I'm checking my work. And what you're going to, I haven't mentioned this yet because we haven't run into it yet. But if you go back to the big gray box, the very last tip in the big gray box says that we need to make sure that our solution is in the domain. Another way to say that is you're never allowed to take the log of a negative number. You're never allowed to take the log of a negative number. If you remember that our parents, the domain was going to be from 0 to infinity. And so negatives are not part of that domain. So what I did here was I took my first solution, I plugged it in for x, and I asked myself, is this causing me to take the log of a negative number? No, it's causing me to take the log of 27. And then I took my second solution, I plugged it in for x's, and once again, I got that I'm trying to take the log base 3 of 27, and that 27 is a positive number. So both of my solutions here are good solutions, and I'm allowed to keep them. All right, this is the end of the second video. Stay tuned for more.